So we are looking at quadrilateral properties. We're going to go through one type of quadrilateral at a time. So today we're focused, well, we're going to see what we're going to be looking at today, but we're going to start by doing some rotations of triangles just to figure out what these are. And there's a reason for rotating the triangles to get this, because it kind of helps us understand why these properties are there. So we can think about it as two congruent triangles being connected together. And that's what a lot of our triangle proofs are going to look like anyway. And we're going to look at some triangle proofs. I don't know if it'll be this week or if it'll be next week. So anyways, let's go ahead and just start with doing these triangle rotations. And remember, if it's a 180-degree rotation, two of the points are just going to land on each other. So we don't need to worry about those. There's only the one point we need to worry about. And the way it typically works, or the way it's really working in practice, is that this point right here, if we look at the top triangle, the point down at the bottom is the one that's being rotated. And this is kind of the arm that's going to rotate around 180 degrees. And it's going to end up right here. So notice we're just creating a straight line by doing a 180-degree rotation. And we can just follow that slope a little further. And by that I mean, if this point is going up to right 1 to get to M, we're going to go up 2 and right 1 one more time, and we've done our 180-degree rotation. So the point's going to end up right here, and then I can connect all these together. Let's just do that for these real quick, just to show you one more. In the next one, I'm going from this point down to right 1. I'm going to go down to right 1, and my rotated point ends up right here. All right, so do the other two of these real quick, and I'll put the rotations up on the screen in just a minute. You can make sure they look the same. Okay, so what we're doing is we're looking at a specific type of quadrilateral. What would you call all four of these? Parallelograms. These are all four parallelograms. We've got parallelograms, rectangles, rhombi, and squares. We're going to look at all four of them, but today we're focused only on parallelograms. So keep that in mind. Even on the right side, and here, let me write this in and then we'll look at that real quick. So all four of these are parallelograms. So let's look at the right side of the page. And we're not doing any of these problems just yet, but this I want you to understand from the very beginning. These are the types of questions primarily that will appear on your test. So you will need to know quadrilateral properties in order to answer these questions. And some of them might be pretty straightforward. Some of them you can see get a little more challenging, and you can kind of decide for yourself which ones look the most challenging to you. So you have to know the properties of the quadrilaterals in order to answer these. And now we have, I also wanted to mention, there are some of these that might look like they are another quadrilateral. Like one of these looks like a rhombus. One of them right here looks like a rectangle. But those are still all parallelograms. So we're going to use the parallelogram properties in order to answer these. So again, we're going to come back to that kind of the last part of class, see how far we can get. But we're going to spend the first part just coming up with the parallelogram properties. So notice this is split into three sections. We've got side properties, angle properties, and diagonal properties for parallelograms specifically. And we're going to derive the properties of all the different quadrilaterals in the same way. We're going to have side properties, angle properties, and diagonal properties for each quadrilateral. So today, again, just parallelograms. Let's kind of investigate what's happening with the sides. So the opposite, okay, let's just start with the first property that we're going to investigate. Opposite sides are parallel. And it's good to look at multiple parallelograms. Don't just look at one of them and decide if it's true or not. But look at all those parallelograms up there. Are all of the opposite sides parallel to each other? Okay. And we'll go ahead and say yes, that's true. Remember, that's kind of the defining characteristic of a parallelogram. So it's not a parallelogram if the sides aren't parallel. So that's basically one of the maybe the most defining characteristic here. But we can look at this a little closer, and I want you guys to be familiar and comfortable with using the slope itself in order to answer that question. So we've got this line right here. I'm going to go up to the very top parallelogram. And the line at the very top, we have a slope of what? So I'm just looking at, just to make sure you're looking at the right spot. Just that right there, what slope were we looking at? Up to right 4. There you go. And for right now, I'm just going to leave it like that. We can simplify it. Well, I'll just do that anyways. We can simplify it to 1 over 2. Let's go to the opposite side. So we looked at the top. Now let's look at the bottom. What's the slope from this point to that point over there? Up to right 4. So that, again, simplifies down the same way. So the reason for doing this is that we can see the slope is exactly the same on the opposites. Now it looks the same, so it's not like we had to do that process. But it is important to understand that the opposite sides have the same slope. If we do that on the right side and the left, we can do this pretty quickly. What's the slope on the right? Up 2, left 2. We can do that. So that's going to be, yeah, it can be 2 over negative 2 or negative 2 over 2, depending on how you're looking at it. But basically that reduces down to negative 1. And on the opposite side, is that still the same? Yeah, it's still the same on the left side also. So my slope here is going to be negative 2 over 2, which becomes negative 1. So we have the same slope on opposite sides. I'm not expecting you guys to do this for every single parallelogram. I'm expecting you guys to know about this property of parallel lines, that they will have the same slope. Now we can look at the next one. This one we can kind of just visually inspect. To get the real answer to this, we'd have to use Pythagorean theorem. But we're just going to kind of visually check. Are the opposite sides congruent? We know they're parallel. Are they also congruent? Yeah. That is the case. So again, just visually, they all appear to be the same length. And some of them we can double check for sure, like this third one down. The left and the right are both 2 because they're going along the line so we can tell. So yeah, opposite sides are congruent. And we will come back to looking at some proofs for some of this stuff on another day. And proofs are actually really helpful for stuff like this to determine what the properties are. All right, so adjacent sides are perpendicular. This one's a little less intuitive here. But are the adjacent sides perpendicular to each other? No, they are not. So if the adjacent sides were perpendicular, we need to see what angles? What kind of angle? 90 degree. We're not seeing 90 degree angles here, so no, these are not adjacent. And we're going to come back to the 90 degree angle when we get down to the angles. Okay, and this one's really obvious. Are all 4 sides congruent to each other? No. Like, and again, this third one is an extreme example. Short there, pretty long there. So no, the 4 sides are not congruent. So we have 2 side properties when it comes to our parallelograms. Okay, angle properties. So now we're only focused on the angles. Are the opposite angles congruent? Yes. And this is one where you kind of have to guess a little bit. Do they appear to be congruent? And we can do proofs about this one as well. But for now, if they appear to be congruent, we'll assume they are. Do they appear to be congruent? Yeah, okay. So and we can just look at this angle right here. Like up in the second one, I marked one of the angles. And this one right here, they appear to be the same. And we can think about this a little further. All I did was rotate the exact same triangle around. So, of course, it's congruent triangles. We're going to have the same angles. All right. Consecutive angles equal 180. This one's a little bit confusing at first. It has this diagram off to the right that kind of explains what the consecutive angles mean. And luckily, there's an easy way of answering this if we remember something about these parallelograms. Well, the very first property we talked about is the fact that the opposite sides are parallel. So I'll just come to this bottom triangle, and I'm going to draw these parallel lines, parallel arrows in. If these are parallel lines, then what would you call these two angles that I'm about to mark? What's the name for that angle relationship? Same side interior angles. All right, we already learned same side interior angles are what? Congruent or supplementary? They add up to 180. So same side interior angles are supplementary. So yes, this property is true. And I'm just going to add off to the side here as a note that these are same side interiors. Another relatively easy question here. Are all four angles in the parallelogram going to be 90 degrees? No. In fact, not a single one of these angles on the screen right now is 90 degrees. But again, the way we can check for perpendicularity with slope is that, what do we know about the slopes of perpendicular lines?
They're the same.
They're not the same.
They're different.
Okay, yeah. Okay, so we've got that far. They are different.
Yeah, about perpendicular.
They are what?
Perpendicular, right?
Yeah, for perpendicular, what do we know about the slope? So if the slope of one line is 1/2, what is a perpendicular line going to have? The negative reciprocal. So you just take whatever your fraction is and you flip it and you make it negative, and that'll be a perpendicular line. So you can check this with slope as well. So if we go back up to the first one where we actually wrote stuff down, the one slope is 1/2. A perpendicular line should have a slope of what?
2/1.
Close. Negative 2/1. So we should have negative 2/1 if we have a perpendicular line. We have -1. So those are not perpendicular. All right. So those are the angle properties. And again, we're going to look at the same properties for all four quadrilaterals and determine yes or no. We're not going to add in any new ones. So now we get to the diagonal properties. And this is the part where we need to understand what the diagonals are. It's just where we connect the two opposite vertices. So I've got two of them are already connected because of the way we constructed these. So we've got one diagonal for each parallelogram. I'm going to go ahead and add the other diagonal for all four of these, because it's good to kind of get a view of all of this, all of the diagonals, so we can kind of have a good visual to determine what properties are true. And just to tie this all back together, remember, your questions are going to look like this. So you're going to have diagonals cutting through the quadrilaterals, and you need to know things about the diagonals. You're going to have angles inside. You're going to have side measures, and you need to know all these different pieces of information. All right, so let's find out what properties we have for parallelograms. The diagonals. Look at all four sets of diagonals. Does it appear that the diagonals bisect each other? Okay, and they do. So that is the case. So again, that's another thing we can prove. For now, we're just going to visually say, yeah, that appears to be the case. Okay, diagonals are congruent. Do the diagonals appear to be congruent to each other? No, and we have some extreme examples. If we look at the bottom one of these down here, notice the one that's going at a slant here looks much longer than the one that's vertical. So yeah, obviously these are not going to be congruent. Are the diagonals perpendicular to each other? No. We need to see them intersecting at 90 degrees, and that's not the case. This one's a little bit trickier. Diagonals are angle bisectors. Okay, and this one is a little tricky. For this property to be true, both diagonals need to bisect the angle. Okay, and the angles we're talking about right here, I'm going to draw it up on the screen. Let me do it in a different color. So these angles that I just marked in purple have to be cut in half. Does it kind of look like that might be the case? 50-50? All right, so it might be true there, but let's check the other one. Does this angle appear to be bisected? Okay, this one very clearly is not being bisected by the diagonal. All right, so because it's not true for both diagonals, this is not a property that parallelograms have. So we're going to say no. And let me just say, when you have this property, it's going to be very obvious. It's not going to be kind of like, oh, I can't tell, maybe, maybe not. It's going to be very obvious which quadrilaterals have this property. But there you go. There are 5 properties that are true for your parallelograms. And I'll give you guys a heads up even here. Rectangles, rhombi, and squares. Would you call those parallelograms? Yeah, they are parallelograms. So they're going to have these same properties. Every rectangle, rhombus, and square is going to have those 5 properties you've got right there, but they're also going to have other properties, and we'll investigate those. But for today, just focus on these, and with the time that we have, we're going to look at a couple of problems on the right side. But as we're looking at these problems, you're going to need to go back and refer to these properties. I'm just saying that very clearly so you know where to go back and check. I'll also mention right now, on the quiz, the test, when you do this, you'll have access to all the properties. So you don't have to have the list memorized. So let's look at, I just wanted, with the time we have, let's look at one of the more complicated ones. Let's jump down to F. So if we're looking at F, all right, so we're going to look at this right here. And what I want you guys to be thinking about is, I mentioned we have side properties, angle properties, and diagonal properties. Look at the problem and kind of determine which ones of the properties we're going to be focused on. We don't have any side information in this diagram, so we're not going to be looking at our side properties. We do have some diagonals shown, so it could be that. We also have angles shown, so it could be our angle properties. So you might need to look at those properties. Which one do you think, actually before we even worry about that too much, is there one of these x and y that we can solve for right away?
Yeah.
Which one?
Y.
Okay, how are we going to solve for y? So this is actually
Opposites of 28.
no. Okay, well, this is one. Go ahead.
Triangle sum theorem.
There it is. There it is. Triangle sum theorem. I was about to give you a hint that we don't even need our quadrilateral properties for this. But yeah, this is a triangle. And it might be difficult to see the first time, but just because you're focused on the parallelogram. But yeah, that's still a triangle, and it still has a triangle sum theorem that applies. So let's just solve for y real quick. I know that 28 plus 115 plus y will all add up to 180. So can anyone tell me what 28 plus 115 is? Close. 143. And then we can solve for y, subtract 143 from both sides, and you get 37. I'm just going to write that in as my answer right here. So y is now 37 degrees. We didn't have to use a quadrilateral property, and that could be the case on the test. You could say, oh, that's just triangle sum theorem. Those are just alternate interior angles. Those are just same side interior, stuff like that, which kind of ties into our properties, but you get the idea. x, we are going to have to do something a little different. We're going to have to think about the properties that are true for parallelograms. What do you think? You could. I'm not sure that's going to help us here. Well, okay, so we're using a property there. How would you describe that property that you're using? Yeah. There it is. Yeah. The consecutive angles are supplementary. All right, so if we ignore everything else in this diagram, in fact, because I can do this, I'm going to ignore that 115 in the middle. I'm going to ignore these lines. Maybe we'll have these lines right here. But basically, these two angles right here are going to be supplementary. Okay, that's one of the properties, and this is why we're going through this practice, so you can see it happening. Those two have to be supplementary, and we already know what 3 of these 4 angles are that make up the 2. So we can work from there. So what is my equation going to look like for this? There it is. Well, equals 180. Yeah. So the 50 and 28 makes up this angle on the left. So I'll just kind of show that. 50 and 28 plus 37 and x will add up to 180. And you can solve from there. I'm going to give you guys a minute, and then I'll ask what you guys got for your answer. All right, so for x, you guys had time to look at that. What is the value for x? 55? Close. 65. All right, no worries. But this is another one of those tests where if I see that you did the math and you had it set up correctly and it was just a calculation error, then I would give you partial credit, or even in that case, I might give you full credit. Sometimes it's just like a really simple, we accidentally added quite a little bit wrong. I'll sometimes give full credit. So there you go. Now the other one, and we don't have time to finish this, but I just wanted to look at it really quick. Number G, letter G, I guess. The property here, we're looking at sides. What do we know about opposite sides of a parallelogram? They're congruent. So we're not going to solve this, but we can set up a couple of equations. We know that these two sides are congruent and these two sides are congruent. That's one of the properties that we have. So I can set up a couple of equations. 3x minus 5 equals x plus 25. Well, now we can solve for x. And the other sides are going to be congruent also. 4x equals 2y minus 12. Once we know what x equals, then we can solve for y. All right, so we're just going to stop right there for today. And tomorrow we're going to start with practicing with some of the parallelogram stuff, and we'll move on to rectangles also.